Over the last year, more than 100,000 flights have crossed airspace where GPS simply stopped telling the truth. Pilots see their planes jump 50 kilometers in a blink. Airports have cancelled landings. Someone is jamming the sky. But in a handful of labs, there's a device that does not care. A compass you cannot jam, because it navigates with atoms. Here's the dirty secret of GPS. The signal is pathetically weak. Each satellite broadcasts from 20,000 kilometers away. By the time the signal reaches your phone, it's a whisper. A cheap transmitter can simply shout over it. And you can do worse than shouting. You can whisper lies, feeding aircraft fake positions. In 2025, that's exactly what started happening. So, how do you navigate when you can't trust anything coming from outside? Simple. You stop listening. A quantum compass receives nothing. It transmits nothing. It asks only one thing. What are my own atoms doing? Inside, a cloud of atoms is cooled by lasers to a few millionths of a degree above absolute zero, until each atom becomes a slow, calm matter wave. Then a pulse of light does something impossible sounding. It splits each atom into a superposition, two versions, taking two different paths at once. Moments later, the paths recombine, and the atom interferes with itself, like ripples meeting on a pond. If the device accelerated or turned while the atom was split, the ripples land differently. Read the pattern, and you've measured your own motion, with absurd precision. Ships and planes already do this with spinning gyroscopes, but mechanical parts drift, tiny errors pile up, kilometer after kilometer. Atoms don't drift. Every rubidium atom in the universe is perfectly identical. It's a measuring stick that never wears out and never needs calibrating. The UK has already tested one at sea with the Royal Navy, and in 2025 they took it to the Arctic, where GPS barely works at all. Honesty check. Today, a quantum compass fills a rack of equipment, not a pocket. It's early, but it cannot be jammed, spoofed, or switched off from outside. And navigation is just the beginning. The same trick, atoms as perfect sensors, is quietly getting spooky. Your brain runs on electrical currents. Those currents make magnetic fields, hundreds of millions of times weaker than Earth's. Quantum magnetometers can hear them. In 2018, researchers in Nottingham built a wearable brain scanner, a helmet that watches thoughts move while you move. In 2022, a team in Birmingham pointed a quantum sensor at the ground and found a buried tunnel through solid Earth by its gravity alone. Every object with mass bends gravity a tiny bit. Two falling atom clouds can feel a void beneath your feet. Nothing can hide from gravity. Here's the beautiful irony. Quantum computers struggle because quantum states are fragile. The slightest disturbance ruins them. Sensors flip that weakness into a superpower. If the slightest disturbance changes the state, then the state is a perfect detector of disturbances. That's quantum sensing, the fragility that breaks quantum computers, turned into the most sensitive instruments humans have ever built. You already carry the first quantum sensor's descendants. GPS itself runs on atomic clocks. The next generation just won't need the satellites. So the next time your map glitches, remember, somewhere a cloud of cold atoms is learning to find its way home. No signal required.